welcome to the next video in our geometry sequence. Today we're going to talk about triangles and similarity. So two triangles are similar if their corresponding sides are proportional. Now we can rewrite that as if the corresponding sides of two triangles are proportional, then the two triangles are similar. You may or may not remember, but a proportional, all that means is that the ratio of the corresponding sides are the same. Essentially, if the two corresponding sides, if their fraction reduces to 1/2, and that's true for all corresponding sides, then all sides of the triangle are proportional, and therefore the triangles are similar. We use the little squiggle or tilde from our logic unit as a symbol for similar. So we use tilde with equal sign for congruent. For similar, we use just the tilde sign. Note that corresponding angles are going to be congruent in similar triangles. Sides are proportional, but the angles are going to be congruent. So an example of proportional would be 1/2 and 8/16. Since 1/2 is the same value as 8/16. Another example, 5/6 is the same as 35/42 because they're both can be multiplied by a factor of 7 to get that value. However, 5/6 equals 30/42 is not, because 5 increases by a factor of 6, while 6 increases by a factor of 7. Now we're going to look at an example of two triangles being similar. Here we have two triangles to be similar. So let's look at some work. If we look at the diagram, we see that angle D is congruent to angle L, angle F is congruent to angle K, and angle E is congruent to angle J. Therefore, the corresponding sides are side DE and side LJ, side EF with side JK, and side FD with side KL. Remember, by definition, two triangles are similar if their corresponding sides are proportional, or if the corresponding sides of two triangles are proportional, then the triangles are similar. So, does the side lengths, so please note that this notation is a little off because it's not supposed to have a line on it, but do those three ratios equal the same value? What we're going to do is we're going to check. So, if we take side DE and side LJ, and we do that division, we get 2/3. If we take the other corresponding sides, we get EF, which corresponds with JK. We get 2/3 when we simplify. And then we finally have our FD over KL, which we get another 2/3. Since each ratio simplifies to the same value, they are considered proportional and therefore are similar. Since all three ratios reduce to the same fraction, the triangles are similar by definition. So now I want you to practice. Can you determine if these two triangles are similar? Please pause the video to give yourself time to show the work to find the answer. Hopefully you've paused the video so you can try to see if you can understand the quick definition of similarity. Here's the answers. We know that the corresponding sides are PQ and YX, PR and YZ, and QR and XZ. We know this by the way that the angles are drawn and marked. So we have to check, do the three ratios equal each other? And the answer is yes. Each side simplifies to the ratio of 5/2 or 2.5 if you're doing the decimal. And then we would show here, using our little symbol, that the two triangles PRQ is similar to triangle YZX. Just like in congruent triangles, we have to make sure the corresponding parts match up. So Q and X match up, Z and R match up, and P and Y match up. So now we're going to use the definition of similar to find values. Remember that if a triangle is similar, then the sides are proportional and vice versa. So here we're saying we have similar triangles. Can we find a missing value? Here we have CB is 12, ED is 8, AD is X, and AC is, and DC is 7. We're going to note that side DE is parallel to side B or CB. This allows us to have corresponding angles, and because they're corresponding angles with parallel lines, they are also congruent. So we have triangle ADE is going to be congruent to ACB. Since they are congruent, or not congruent, sorry, they are similar. So if they're similar, then we have the following. We know that AD corresponds to side AC. We also know that side DE corresponds with CB. You should note that the numerator of one ratio comes from the same triangle as the numerator of the second one. Since this little triangle has sides AD and DE, those are both in the numerator of my fraction, while AC and CB are in the denominator. You do not have to have the small triangle over the large triangle. You could have large over small. The point is that you'll still have the same ratio at the end for equivalence. So what we have is actually this. So now we're going to fill in what we know. We know that AD is X. We know DE is 8. We know CB is 12. The question is, what's AC? DC is 7, and AD is X. So we're going to combine them together and do X plus 7 for AC. Okay, so I'm going to write this back up here. We have AD over AC equals DE over CB. And I'm going to use my work down here. All right, so AD is X, AC is 7 plus X, DE is 8, and CB is 12. I want to solve for X. When we solve a proportion, we are going to use cross multiplication. This is where we multiply the numerator of one fraction to the denominator of the other, and vice versa. We will get 12 times X must equal 8 times 7 plus X. This leaves us with 12X equals 56 plus 8X. 4X must equal 56. And we divide that out. We should get the value of 14. Just verifying here. 56 divided by 4, 14. So we know that X, or side AD, is 14. And we've answered our question. Here's the answer, 14. Now it's your turn. I want you to try to find the value of X in these two triangles. Please note that these triangles are similar. Pause the video to give you some time. All right, hopefully you paused the video and you tried out the practice problem. Let's go ahead and look at it. The corresponding sides are as follows. Now, since we know BC and ED, we can use that as one ratio. We also know that AE, and we also have BE. Yeah, all right, okay. So we're going to use AE over AB and ED over BC. AE is 9, and AB is 9 plus x. So we're only going to have one x in this one. But we set the ratios equal to each other, and then we cross multiply. We then distribute or multiply. Then we subtract, and then we divide. So we get x is either 22.5 or x is 45 over 2. And that's it. In class, we'll practice more with these and discuss a little bit about how to prove triangles similar.